Here's another problem that can go wrong. Consider the case where we have failures or delays of nodes. And so the network is off doing its thing and we're running a distributed database on it, and then at some point we stop hearing from one of the nodes. So the transactions that are running now, should they commit? Should they abort? Well, that depends on the fate of this node perhaps. So what are we to do if we don't know if the node is alive or dead? Suppose the node is dead. When it comes back up, how is it supposed to recover in a world that moved forward while it was asleep? Okay? All the other nodes might have been doing stuff while this node was unavailable. So what does it do when it comes back? These are issues that we're going to have to handle, and they're quite a bit trickier than the deadlock detection problem. So consider also that not only can nodes go awry, but also messages can be unpredictable in this environment due to the channels that are used in distributed systems. Remember that we have non-deterministic reordering of messages on a given channel. Also that as multiple channels send messages to the same node, those messages can get interleaved in different ways. Finally, we can have issues where messages can be lost. And, a message being lost is like a message being delayed a very, very long time. How long should we wait for this message? We don't know. Maybe it's lost. Maybe it's just very delayed. So let's look at the picture here. The second node is going to send two messages, one yellow, one red, and they should go out in that order. Yellow came first and red came second. The first node is sending a green message. The third node is sending a purple message. And they're all going to be sent to the fourth node. When they actually get sent, something like this could happen. The red message might race off and be the first one, even though it was supposed to come after the yellow message. It was sent after the yellow message. But the yellow message, for some reason, was delayed. Meanwhile, that green message from the first node got interleaved in between the two messages from the second node. Maybe that's okay, maybe it's not. And the purple message was simply lost. It went away. So we get non-deterministic reordering per channel. Yellow and red got reordered here. We get interleavings across channels. The green message was reordered within the red and yellow in a certain way. And we had a lost message, the purple message. Right? So all these possibilities are things we have to worry about. Given that all these messages could arrive in different interleavings in different orders, and different nodes are getting messages from each other, how do all the nodes agree on committing versus aborting transactions? For example, if we were going to send the same messages to every node, each node might get those messages in a different interleaving or even in different orders from given senders. And so we need all these nodes to agree on things, but they may be getting messages in funny orders. So we're going to have to work pretty hard to make sure that they all agree to commit or all agree to abort in a sensible way.